Good morning, MathLovers. So here today I'm with a wonderful problem. It seems to be a problem which connects 11, 12 graders to the 9, 10 graders or even Olympiad lovers. The question is, how many non-decreasing onto functions are there from set A, which is comprised of 1, 2, 3, 4, and 5, to set B, which is comprised of 7, 8, and 9. So I call this as a 11, 12 grader problem because of the keywords that they have used, like onto function and all, not decreasing. So, but if the same question is put forward in a simpler way, and we are talking about five inputs: one, two, three, four, and five. We're talking about exactly three outputs: 7, 8, and 9. So, you're talking about non-decreasing function, meaning the function should either remain same, the output would maybe remain same when you go to the next input, or it would increase. So literally we can understand onto function. People, I would tell you what is onto meaning. Onto meaning all the outputs will be achievable. So 7, 8, and 9, all of them will be achievable. So if for my smallest input 1, if I'm going to achieve 8, then 7 will not be achieved for any of the other inputs, because if it is achieved, then it will become a decreasing function. So that makes us understand that 1 comma 7 graphically is a point in this possibility. Same way, and for 5, I should not be able to reach to 8 or 7, because that means the value outputs for 2, 3, or 4 would have been higher, and then you would have come lower to 5. So that also tells us 5 comma 9 is going to be the final point. So now we are just talking about the number of journey paths that you can go from 1 comma 7 to 5 comma 9. Okay, so let's look into the interesting pathways here. So this is the square rectangular grid that we have to make the movements. We understand. So we got to move like 1, 2, 3, 4 steps horizontal to reach to this point 5. At the same time, to reach to 9, I need to make only diagonal moves, because like I said, it's an increasing function. So there are only two diagonal moves required, because you have to move from 7 to 9. That's only two diagonal moves. And like you have to move from 1 to 5, that is like four horizontal moves. Okay. There are four horizontal things that you need, and you just need two diagonal moves. So this two diagonal moves is compulsory, because when you do a diagonal move, try to understand people. If I do a diagonal move, it also says you have done a horizontal move. So which means instead of four horizontal, I can just bring it back to two horizontal, because each diagonal move involves an horizontal move as well, meaning that horizontally the value has increased by one as well. So now you can recall this. This looks like a probability question now. In how many ways I can arrange two heads and two tails? You would have done this in 9th standard, 10th standard. So the answer for this question is 6 ways, right? Head, head, tail, tail, head, tail, head, tail, tail, head, head, tail. This is how you wrote the all the 6 ways. So same thing here. I just need to make this two horizontal, two diagonal moves. So the number of ways I can arrange that H, H, D, and D will be in 6 ways. So the answer for this question is 6. Total number of non-decreasing onto functions that can be available from set A to set B, where all the outputs, that's what onto means, all the outputs 7, 8, and 9 are being achievable through the inputs. So the answer for this question is 6. So we'll see you with more interesting questions in upcoming videos. Thank you all. MathLovers.